Hello. Yes, so this is a second course managing machine learning projects assignment. My name is Kairav Shah, and this is the assignment solution. And the problem which I have chosen is basically developing an machine learning model to assess credit risk in small to medium sized business lending. So I work as a product manager in the fintech space, where we give out loans to small to medium sized businesses. So it's very important that we identify which are risky businesses. When I say risky businesses, are basically those businesses who do not pay us back. So it's very important, and this is a big problem in the industry. There is not an ideal solution because it's very very specific. It also depends on market conditions. So that's the problem which I have chosen. The success for this will be, success metrics. Defined success would be reduction, not the success metrics, but the outcome metrics or success will be reduction in loan repayment by the businesses, identifying more businesses which are going to be which are going to default in loan repayment, increasing portfolio returns. So overall, if you look at like the loans we have given out and the money we got back from the business, the overall portfolio return, the IRR, ARR should be positive. So that's what we are hoping for. So these are the success metrics. Uh, these are success metrics. These are like the successes which we want to focus on, target variables. The factors would be like, financial metrics, marketing data, legal data of the business. We also want to know the sales data, inventory data, all sort of data. These factors are very very important to even build the features for the model. Output metrics would be model accuracy. We want the model to be accurate. This is a high risk high reward kind of a domain. If we go wrong with identifying a wrong business as risky, we can lose money. The business can lose money, and that can result into lower portfolio return overall. So this high risk, high reward, model accuracy, area under ROC curve, precision and recall. We want the model to predict risky businesses more accurately. So precision and recall are also very important. Data understanding, data gathering, validate data and explore the data. This is a crisp DM process, by the way. Uh, Financial data, inventory data, sales data, marketing data. So we need all sort of data in one single place. Uh, even their social media presence is very important to assess the risk of the business. So this is all the data which we need. We won't be having this data directly from the business. We cannot capture this from the business. We cannot ask the customer to do it. So we need to connect third party sources. That's where the data preparation comes into place. Feature selection comes into place. We want to have all the data feed in from third party sources. Third party sources can be Rutter, which provides us order data. There is companies like Plaid, which provides us banking data of the business. There is companies like Oculus, which provides, like the bank statements of the business. These are all data from third party sources. Third party companies which I mentioned is available, and we can plug them into one single data warehouse. Why I say data warehouse like Snowflake or something is because it is easy to query. We can play around with the data. We can do simple regression with the data and identify features. So this is very important that we bring all the data into single data warehouse. Modeling, we can start with the basic logistic regression. My suggestion would be starting with simple regression model to identify the features, to see the correlation, and then we can later move to random forest, advanced models like random forest, gradient boosting, and those kind of models. Evaluation will be A/B testing the model. With the real time data, it's very important we test the model very very. Uh, uh, and the testing should be very very in a very real time setting, because this is a high risk high reward domain, as I said. Deployment will be, we deploy the model in phases. We deploy the model so that it gives a score of how risky the business is. We constantly monitor because there is a lot of market condition. This kind of model is heavily influenced by what happens in the outside, what happens in the market. So we want our model to be relevant to current market conditions. So that's the crisp DM process. Now we move to the validation plan. So the validation plan is basically, again, as I said, like start with a simple regression, logistic regression model to identify, to select the features. Then we can move to more advanced models like random forest uh, and gradient boosting, which can help us further make the model more stronger. A/B test the model in real-time data. As I said, we want to also have output metrics like precision, recall. These are very important because this is high risk, high reward. We want to accurately predict which are the risky businesses. That's a goal. So that's the validation plan. ML system design. This will be cloud-based system because there is no need to have an edge-based system because we don't need the result very in a very very short span of time. It can take like 1 or 2 days, and that's fine. Considering the impact or the risky nature of this particular domain or what we are trying to predict, it's important that we do it cloud based and we consider all the data set. Offline learning, we want to use full data set. We want to make sure we consider each and every feature, each and every data point, um, in basically training this model or building this model, or basically all the features. We want to consider all the features that goes into the model. Batch predictions, again, as I said, like we don't need to have online predictions. We don't need to have immediate predictions. This can be batch predictions where we push out scores like 1 to 10, between 1 to 10, where 8 being the most risky business, 7 being like little bit less risky. So we can do all sort of batch releases. uh, Further retraining, it's very important we retrain the model on timely basis, because as I said, the model, this kind of business is very dependent on what happens in the market, the industry performance of the business that belongs to, what is happening with the consumer supply demand overall. So it's very important we retrain the model, and we can have scheduled retraining on timely basis for the model. Then we move to the last part, which is potential risk in production. There can be data drift. It is very important we feed the data from all sort of. There can be data drift. There can be skew, because if we feed the model with the businesses only from one industry, for example, or only from one type of revenue size or size of the company, the model can get skewed. So it's very important we feed the model with all sort of businesses, all sort of data, and the more data we have for such kind of a problem, it's the better the model we get. So it's very important to make sure that there is no data drift, there is no training servicing skew. Latency is important when we move towards an ideal state, which is you want to have the risk prediction immediately. So that's an ideal state. It is not so much of a concern right now, but latency can be an issue later when we want real time result, when we want immediate result, whether the business qualifies for lending from a particular company or not. Basically whether the business qualifies for the loan or not. So latency is not a huge problem right now, but it can be in the future when we want to have speed up fast results. Bias can be a huge problem. We feed the data if we have very very uh, low data set, where we have very very less data, very very less businesses. The model can be underfit, and it can lead to bias. So it's very important we feed the model with as many data, more businesses. The more businesses we have as data point, the better it will be. So this is my submission for the assignment. Thank you.